All right, so today what we're going to do is take a look at how we can use a Teacher Desmos math input to actually populate a graph and sort of fill in some points or even just take in some values from a previous slide, some numerical values. So to start off with, we're basically just going to have an example where students are using a numerical model to find some values for a rocket launch. So it's going to ask them some questions like maximum height of the rocket, or how long until the rocket achieves its maximum height, what height above the ground does the rocket launch. And then what's going to happen after they fill those numbers in, this graph over here, so we've already just put the equation in, nothing else yet. Their values are going to show up for what they thought the maximum position was, where the vertex was, the initial height, and the final height will all show up on this graph. Okay, so how do we do this? So first things first, on my input slide, you may choose to have a different title, but what we're going to do is label all of our math inputs. So it's important that you give each math input a distinct label so that later on, when we're using the computation layer, we can actually pull the value from this math input. So if we click over here, I can add a title. So I'm just going to call these inputs part underscore A. So if you can't use spaces, but you can use an underscore. And what I like to do is start with the name of the slide. So in this case, inputs. You can use an acronym or any other sort of abbreviation just to keep what slide this is defined on clear. And then basically refer to which input on the page I'm using. So in this case, it's the input for part A. You can use another title. You could say, height max or something like that, but we're going to go with the just ABC. All right, so we're going to do the same thing for each of these, and let's quickly fill those in. And part C, and finally part D. All right, so now that we've labeled all our inputs, let's go take a look at the computation layer. So before I actually go into the computation layer, what I'm going to do is add my points to the graph. So I'm going to have three final points. I'm going to have a first point that's going to be our initial values. So though part A is asking about the maximum height of the rocket, and then part B is asking about the distance in terms of time, how long it's been traveling when it reaches that height. So if we were to write that as a point, that would be the number that we get in part B for the maximum amount, the time until it reaches its maximum. And then the height it reaches is our part A. And we're going to just put that in as an ordered pair. And we can actually add both those as a slider. It's going to end up down here. It doesn't really matter where it is because it's going to get automatically repositioned when the students put their answer in. You can go ahead and customize that point. I like to turn off drag so that we get a nice round dot, or you can also even change the shape. So that's our maximum point. We can also label that as maximum height and maybe even identify it, A and B. So let's do the same for the other points. So our initial value, that was part C. So that was at 0 as our x value. And then C, the answer the students put in is the initial value. That's our other value. We'll add a slider, throw a label on that, and say initial value. We'll call that part C so the students know what we're talking about. And turn off drag, change the color, and there we go, part C. And finally, part D, the distance it travels. So our height is 0, and we're going to put in as an ordered pair that way. Add our slider, and then label that as D. Final distance. All right. Once we're satisfied that we've put all of our points in correctly, we're going to click Done. So the naming convention for these variables doesn't matter too much, but what is important is that they are memorable, so you know what A actually does in this particular pair. Like you can tie it back to what your variable's names. If you're doing something that's a little more complicated or doesn't have things labeled as nicely as ABC, it might be helpful to just keep a piece of scrap paper beside you and kind of note down, oh yes, math input maximum height is going to correspond to the variable M, capital M, something like that, just so that you know what is what. So once you're happy with all that, click on Done, and we're going to actually edit the computation layer. So it's just this button here, and you're going to pop up the computation layer. So what we're going to do is use one of the what are called sinks for the computation layer for the graph. And these are just things that take in a value. So we want to use the number sink. And this lets us edit one of the variables or sliders that's showing up on our graph. So if you remember, we had 4 of those. We had A, B, and C. And let's just do the first one. So we want to edit A, and we want it to take the value from from inputs. So that was our slide, according to the naming convention we've chosen. You can use a different one if you don't find this useful, but this is how I like to do it. So inputs part A, so that was the math input from the input slide for part A. And then we're going to put a dot, and then we want the numeric value. So if the students put units in meters or anything like that, we want the calculator to just get rid of that and only give us the number. And that's what putting dot numeric value after it will do. And then basically we're going to repeat that exact same process for each of our variables. And after you're done that, you're basically good to go. So one thing to watch out for when you're doing this is if you have variables that have similar names, that can get confusing. The other thing to keep in mind, and this is why it's important to make sure that every input has a unique name, is if you say identified your variables only as, part A, part B, part C, but then you had a different slide and you also use those same names, the computation layer is going to use the most recent definition of that, and that can lead to some kind of strange behavior. So it's important you give everything a unique name if you aren't totally sure what you're doing. All right, so now that we've put in each of these values, we can click Done. And now what our graph is going to do is actually take the values from the input slide and graph them for us. So right now, if we preview, it's going to actually show up as blank. That's okay, because we haven't put our inputs in yet. So let's go do that. So let's just throw some guesses in. The maximum height, well, something above 20, let's say 25. And we can even put our units. It doesn't matter. The students can put them in. They can not include them. You'll be able to see that as the teacher on the Teacher Desmos screen, what they've chosen, if you want to be checking in for those units or not. But the graphing portion won't worry about those. That's really nice. And we won't have to worry about, making sure the input's perfect. How long until it? Let's say 2 seconds. And even for things like seconds, actually this is secant, but it looks pretty nice. What height above the ground does the rocket launch? Well, that's easy, 20 meters. Read that right from the equation. And how long does it take for the rocket to return to the ground? Let's say 3 seconds, and we'll just leave that blank. So they can hit submit or even not hit submit. And when they go next, we'll see that all of those answers we put in are actually now graphed on our graph. And of course, you can put this on the sidebar if you want the scale to be a little bit smaller, a little easy to see on a smaller screen. But that's all there is to it. So we can see our final distance of 3 is over here, our initial value of 20 over here, and then our maximum height at 25 and 2 is over here. Oh my goodness, maybe I should go back and redo my calculations. And that's all there is to it.